So my name is Nick Nellis. I'm a DevOps engineer at the weather company. I work on the core gateway team. And we're going to talk about our use of Istio and how it's making our lives easier. So to start things out, I want to give you a little background history on our company. Originally the Weather Channel. After some acquisitions and bringing in some other companies, we renamed the parent company to the Weather Company. And then in 2016, we were acquired by IBM. So I am now an IBMer. So today we want to talk about api.weather.com. This is the main way that we build, or we sell and distribute weather data. And we built a platform around this known as the Sun platform. We are currently home to over 40 microservices that serve weather data. We do billions of hits per day, and we operate worldwide, mainly in 4 regions. And so if you look at the weather.com, you can see I've highlighted here a bunch of APIs that are actually being called through api.weather.com. So you can see that the weather.com has many microservices behind the scenes. And different microservices are called on different triggers. So if you had a winter weather advisory, the alerts API would trigger that. So this I think has 5 or 6 listed here, but there are many more depending on the pages that you go to. We also have integrations with Android and iOS natively, and you would know if you're calling api.weather.com if you see the weather channel icon on your weather app, or some say weather.com. So we also serve traffic to these as well. So the Sun platform really sits between those platforms that I showed and the weather APIs that serve the weather data. And we serve a number of functions for both clients like you hitting the weather, as well as the developers who are making these APIs and distributing their weather data. So we perform about 7 main functions: authentication, authorization, some API key management. We have a sales pipeline. So as a development team, you enroll in our platform, you have a sales pipeline that they can take your weather data and go sell it and distribute it. We do edge caching, routing, and billing. And so these are the main functions that my team serves. So the existing Sun platform was homegrown. It's cloud native. We have a router, a main gateway, and a cache generator. And the cache generator is pretty important to us. It helps us align requests that look like other similar requests. So if you make a request to get the weather in Copenhagen, most likely somebody's already made that request. So we build these cache templates known as edge side includes that will also serve you the same cache data that somebody else might have already asked for. We have 3 also homegrown auth and billing applications. We run everything in Docker, and we've recently migrated to Kubernetes. We use CloudWatch for our HTTP monitoring, and that'll be important as we get through the Istio slides. And something to talk about is our deployments. We do them every 2 weeks, and that seems very slow in this fast-paced world. And there's a lot of reasons for that. Our homegrown solution currently, if we want to add a new API or new routes to our system, we need to do a new build and a new deployment. And so our builds and deployments are really dependent on our upstream servers or our upstream teams. So if a team wants to add a new endpoint, we align them all together every 2 weeks. And we become dependent on those changes in that stream. So at times it's kind of painful to manage. And our deployments take hours currently. So these are some points that we really want to address. So I want to talk a lot about the routing, and because this is a big core functionality that we offer. We currently route to 40 load balanced backend services. So every person who enrolls with us, it's not service discovery. They give us an endpoint, and then we call their app through api.weather.com. The APIs of the 40, they're managed by many different teams. So we don't really manage those APIs. We just manage that the traffic gets to them and the other platform services that we offer. It's all HTTP path-based routing, so a team will give us a path that their weather data is under, and we'll make sure that weather data or the requests make it to them. But before we send a request to them, we actually intercept those and generate the cache template. And with that cache template, we can also determine if that data has already been cached, and we can serve that before the request goes all the way to the backend. And then some stats. We do 400,000 requests per second globally. About 60% of that is cached. And so we can take that down quite a bit initially. But of those 60% that are cached, about 90% of the data that we serve is in that cache response. So it reduces our load significantly by generating these cache templates. And that leaves about 20,000 to 50,000 requests per second per region of the 4 regions that we serve. So it's a lot more manageable. And that's really important. So when we looked at Istio, we knocked it down to probably about 50,000 requests per second is our requirement per region or gateway. So this is a very, very simplified diagram of the routing platform. The edge cache, it comes into our gateway, which is intercepted and then sent to our cache generator. Our cache generator then actually responds on behalf of the weather API with this cache template. The cache template goes back into our edge cache, and then depending if it's cached or not, edge cache may make another request to the actual weather API to go get the data, but if it's cached, it'll just serve the cache data. Some things to note is that we log our access logs to an object store, and then our HTTP metrics are pumped to CloudWatch. Oh, another big important thing, you can see that our gateway is running in Kubernetes, but and we were pretty early adopter of Kubernetes on our team, but 95% of the weather APIs do not exist in Kubernetes within our mesh or anything. They are in VPCs and load balanced. So that's a big challenge for us when we were looking for tooling, is how do we route outside of our mesh? So some of the areas of improvement that we really wanted, that we were looking for a tooling to help us with, was deployments. We wanted to get rid of those completely for routing changes and make it so teams could self-service routing. They could add routes at will based on some validation, and that we really wouldn't have to interject as much. So it would allow a lot faster work streams, and then teams could switch routing really quickly, especially in production if they added new versions. And we didn't really offer a lot of tooling in the routing world. So we want to add circuit breaking and retries and blue-green to those developers. So if they're using our platform, they could try canaries and blue-green testing. And one thing is our visibility is not great right now, and I'll show you an example of that next. So the HTTP monitoring, definitely we needed to improve. We wanted to alert teams when their APIs are misbehaving. Right now, it's a very manual process. And then we also wanted changes to be very transparent. So we wanted to make our platform very open and very transparent to whoever's using it, so it's a lot easier to use. So this is an uh-oh moment that we had a couple weeks ago. And when we have uh-oh moments, they're usually big. So we had an issue, and we peaked at 500,500 errors per second, or per minute. And so this was bad. And we probably got alerted late, because as you can see earlier in the hours, we got some small spikes of 500s, and a lot of times those are just a backend that had some weird requests that they couldn't serve. And mind you, we have 40 different backends that flow through our system. And so this doesn't really tell you who's causing the issue. It could have been us, and it also could have been one of the backend APIs. So we were slow to respond initially. We don't have the HTTP metrics that we want or that we need, so we actually crack open access logs. In our environment, we generate 1.4 terabytes of access logs a day. And so cracking open access logs, you can get like a 2-minute window that's reasonable to download. So we were slow to respond. We ended up finding out that it was a backend that was causing these 500 errors. And so we had to contact them. And we don't currently offer many ways for us to help mitigate their issues. We pretty much just route traffic to them. So they knew that they couldn't serve this request that they were getting, and we couldn't really do anything about it. So they ended up having to patch their system and then do a deployment on their end. We couldn't circuit break, we couldn't cut off traffic without doing a deployment. So this kind of was an eye-opening moment that we needed to address. And if you look at the timeline, it took about 8 hours to resolve. So you imagine how many 500 errors we threw. That was a lot. And that brings us to Istio. So we did a lot of searching for different tooling, and a lot of those issues that I mentioned, we probably could have patched or brought into our system. But there was a great talk on the keynote last week that documentation is hard to upkeep. Every time you bring on new developers, they have to relearn this code that has been written before. So we were really looking for tooling to come through and save us. And we eventually landed on Istio. But why did we land on Istio? And the big thing is that it's a single platform for many tools. It integrates with a lot of things, and it takes care of a lot of things for us. It was significantly less code for us to write and document, and there's really good documentation out there about Istio already that if we brought someone on board, we could just point them to the Istio site and have them follow there. A big thing that we really like, and being a part of IBM, is that the enterprise support and testing of Istio. So they're backed by IBM, Google, Lyft, and you know they're doing a lot of good work behind the scenes. There was a talk earlier about performance. And so there's teams of people already performance testing it, regression testing it. And that's something that we don't have to do now. We can do a testing on top of that. So we're really happy that their use cases seem to be even bigger than ours that they're targeting. So we know that we can fall under the Istio umbrella, and it should be able to support our load. It's also cloud agnostic and cloud native. The cloud agnostic one is very important. In the newer version, 08 I believe, they're working on multi-cluster support. So you can run Istio in multiple clusters and multiple clouds, and with a seamless experience. So that's also very important for us. So we started looking at our platform, and we started seeing a lot of sailboats everywhere. And we were like, wow, Istio can just replace everything. We can go home at night and sleep. But in fact, it doesn't really replace everything, but it does integrate with a lot of tooling. And specifically, routing and monitoring is something we probably could replace with Istio, or have replaced with Istio. But it integrates with billing systems and authentication and authorization. So it was really appealing to us. Down the road, we could try and integrate it more into our system. But initially, we targeted routing and monitoring. So I'm going to talk a little bit about the routing. It's pretty neat, and it's for the 08 version, which hopefully will be cut in the next couple of weeks or a week or two. And it has a lot of functionality that we helped work on and test so that we could run our workload. So I'm going to walk through a pretty simple example, and this is for our current weather. So every time you ask for current weather, this is kind of the flow that would go through Istio. And I put up the Istio components here that we use, and they're all in the 08 version. So in the earlier versions, you probably won't see the same names. A lot of things got renamed. So traffic will come in through our edge cache into our mesh. It'll hit a new concept, which is the Istio gateway. And that gateway will decide where that request gets routed. And we intercept it, and we send it to our cache generator. And then that'll go back to the edge cache. And if it needs to retrieve the data, it'll actually go back through the gateway and then to the current weather API. On the right side here, it shows kind of what the cache generator is actually doing. So if somebody calls our current weather endpoint, which is v3wx observations current, the cache generator actually changes that URL and adds /origin in front of it. So if it does make a second request, we know by path-based routing that request actually needs to go to the backend. And this is an ESI template. A lot of edge servers support this as well. So this is probably the most important piece of Istio that allows us to do this. If we go back one slide, you can see the current weather API does not exist in our mesh. It's load balanced, it's sitting in a VPC. About 95% of our APIs are just run on virtual machines, and not in Kubernetes and not in our mesh. And so service entries are the single most important piece probably to us. And what they do is they allow you to take external services and bring them into your mesh and treat them very similarly as if they were native. And it's very powerful for people who aren't all in Kubernetes or not in your service mesh. So what we do is we just add an endpoint. So currentweather.internalweather.com. And so now Istio knows about it. It knows how to route to it. It knows how to treat it similarly to something in the mesh. We just define a port. And so currently we have 40 service entries. They're dynamically updatable. So if a team decides they want to change their backend endpoint, we can just update that in real time. And you can use MTLS. We haven't used it yet, but it is available. So the gateway is a very new piece. It kind of replaces the ingress controller in the newer version. And this is our main point of entry. So we're defining that everything from api.weather.com comes in on port 80. And so what we can do with these gateways, we can assign specific route rules to this gateway so it knows how to manage those routes and forward them onto our service entries. You can have n number of gateways, so it's a lot more extensible. And if we wanted to have a different control plane for different types of requests, we could have different clusters of gateways. And they just run Envoy under the scenes. And you can also do it in an egress. So the gateways are supported in and out. So the first routing rule that we put in here is the intercept. We gotta intercept it and send it to our cache generator. So we take that v3 WX observations current and we steal it and we send it to the cache generator. This is the new route rule if you're familiar with Istio, and these are also dynamically updatable. And if you note that there's a gateway selector, so if you had multiple gateways, you can choose specific ones or you can just say mesh as a whole. But we assign this to the ingress. So then this, if a request is coming, it needs to go to the origin and fetch that new data. This is the route rule that we use. So we look for the origin request, so it makes it very easy for us to identify if this needs to go to a backend. And then on the way out, we rewrite it back to its original URL. So the backend team actually doesn't know that we did this. We tell them about it, but they don't actually need to care what we're doing internally. And we can do a lot of things with these new rules, specifically in the 08 release. Istio already supports a lot of retries and individual timeouts, but outlier detection and some other pretty neat circuit breaking you can do with this new route rule, or these new virtual services. So monitoring, this is probably the thing that catches the most people, why they would want to use Istio first. And monitoring is really baked out of the box in Istio, and that's really appealing to us, because it was a lot more powerful than what we currently have. This is a little example that kind of shows you the isolation of what you can monitor. So each of these different lines here represent a different service and possibly a different response code. So we can do a lot of targeted alerting and monitoring of our service backends just natively with Istio, and it's really powerful. And it was something that we didn't even have to really build. With Grafana and all these metrics, we can actually now tune dashboards for specific backends. So if your team doesn't have great HTTP monitoring, we can now offer you dashboards where you can actually come and see the traffic that's coming to your backend, and it'd be a specifically tuned dashboard for you. And we don't actually have to change much. We put the variables at the top, and this is the default Istio dashboard. So they just select their destination, or their app as a destination, and they can see all the traffic. So this is once you get all of these metrics, you can do some pretty cool things. So we take these metrics that were sent to Prometheus, and we actually pump them into Netflix's Visceral. This is a really cool visualization, and it actually has some really big benefits for us. So what this is showing is this is our mesh, from the internet to the mesh. And this is a demo that I set up where there are some backends that are not healthy. We're showing about 27% error rate, and it's a very small load, about 100 requests per second. But we can zoom in, and we can see all of our mesh. And this is from our gateway to those external services as being treated natively in Istio. We can then filter down to the endpoints that are not healthy. And in this case, they just don't exist to prove my demo. So we filter down to these endpoints that don't exist. And you can quickly identify where the errors are happening by the red dots. So red dots mean 500 errors. So we can click on one of these endpoints and see when those started. And you can see here this one never really existed. So we know that it was a 100% error rate. But we just found this issue within 15 seconds of popping open the dashboard. Previously, it took us hours of scraping through logs. So this is very important to us, being able to identify issues very quickly when we couldn't in the past. I also coined the term Istio, so kind of a cool term, a cool dashboard that we can hopefully offer in the future with Istio. Gives you a little more than the current service graph offering. So where are we today? We've been using Istio for about 8 months. API.weather.com and our large load is currently not yet in production. And the reason for that is the 08 release that is being actively worked on. It has a lot of the features that we need to be in production. We've done a lot of extensive testing with earlier releases, and they do seem to already serve the needs that we have from a load standpoint. And we're actually pretty happy with the status of Istio. But we just need some of the functionality to run this in production. We do run some smaller APIs though with Istio in production, and that's been really beneficial in working with Istio in a production-like environment and kind of understanding how it works and some of the quirks maybe that might need to be ironed out. You treat things a little bit different if it's in production. So we run the 07.1 version in production for these small APIs, and we're actively working with the Istio community on the 08 support. So some advice for us who use Istio, and if you're looking at using Istio, is start small. Ingress is a very easy way to get started with Istio. You can get the metrics. The sidecars are often difficult. As developers, a lot of time, you want to just throw that sidecar in there and see your metrics come through. But there's a lot of things you have to think about by adding that sidecar. And so you have to play with it and get used to it and understand what Istio is doing for you. If you're running a current version of Istio, your upgrades have to be tightly managed. Up until the 08 release, a lot of functionality was in flux. And this 08 release is really going to kind of nail down what we want to offer for the 1.0 release, which should be coming in a couple months. So stability is coming, and you're definitely not late to the Istio party, but it'd be a really good time to start checking it out after this 08 release is released. So as a recap, Istio allows us to resolve issues a lot faster, and I just showed you an example of that. We now have the ability to offer back when APIs are having issues, we can offer some sort of mitigation for them. So if they know that they're going to have problems, we can circuit break, we can cut them off until they're healthy again. It allows us to be way more transparent in the routing. Currently, teams have to come to us and we have to help investigate how traffic is routing to their system. But Istio, with the telemetry and the monitoring, allows us to be very, very transparent about what's going on to a certain backend. It reduces a lot of custom code, and this is a really nice feature when you go from a homegrown system. And we also get to dynamically update routes, and it allows teams to really try things out in production, and they could release kind of beta APIs and try them, and we would allow that to be a lot quicker. And so a lot of advantages for our use. So thank you. So I don't know if we have any time for questions. If you have any questions, come up to the mics, I was told. Do you have a question? Go for it. Yeah, so the question was, how do we do an in-place replacement of our current routing system? And the big thing is making sure that we have feature parity. We want to make sure that when we drop this into one of our regions and we're going to slowly migrate traffic over to it, that we have that feature parity. And we've been doing a lot of non-prod testing for that to make sure that from the backend perspective and the client perspective, you won't notice a difference. And the '08 release really allows us to offer that feature parity. So our current routing mechanism, our gateway, was actually written pretty well to a routing spec. So it made it easier for us to cut over when we're ready. Probably within the same cluster, yeah. Yeah.
Do you do any distributed tracing with Istio?
The question was, do we need distributed tracing with Istio? And not yet. Like I said, you need to start small. We definitely are going to, that is a big thing we want to target. But because our mesh is very, very flat, we don't need it right away. The monitoring that Istio already gives us is pretty sufficient for our case. But we definitely are targeting it. All right, well, thank you guys.